Part 1. The Cold Spot. Hear that static between radio stations? About 1% of that noise isn't coming from Earth. It's the Big Bang screaming at you from 13.8 billion years ago. We call it the cosmic microwave background. For a long time we thought this background radiation was smooth, uniform, boring. Then we looked at the constellation Eridanus and found a problem. A massive cold spot. It's 1.88 billion light-year wide, and it's way colder than it has any right to be. Physics says this spot shouldn't exist. It drives cosmologists crazy. At first we thought it was just a measuring error. Then some thought it was a supervoid, just a huge lot of nothing. But the math hints at something stranger. Imagine our universe is a soap bubble floating in a dark room. Now imagine another bubble floats by and bumps into us. They don't pop. They just press against each other. That cold spot, it might be the dent left behind. A cosmic fender bender. Welcome to the multiverse. It's not just for comic book movies, it's where our math actually points. But before we get ahead of ourselves, we need to clear the air, because most of what you think you know about this is total garbage. Part 2. Common misconceptions. Let's kill the myths first. Movies lied to you about the multiverse. You know the trope. In this universe, you eat toast. In the next one, you eat cereal. In another, you're Spider-Man. This assumes you and your choices are the center of the universe. Sorry to break it to you, but physics doesn't care about your breakfast. Real multiverse theories run on hard mechanics, quantum fields, and geometry, not your decision to wear a blue shirt. There's also this bad idea about infinity. People think infinite universes mean everything happens. That there's a world where gravity pushes up or where you're made of cheese. That's not how infinity works. Look, there are infinite numbers between 0 and 1, 0.1, 0.01, 0.001. You can count forever and never get to 2. Same deal here. You can have infinite universes and they might all follow the exact same rules. Reality isn't a vending machine that gives you whatever you imagine. So if it's not about your choices, how does the math actually stack up? It usually boils down to part 3, the 4 multiverse theories. So how does it actually work? Theory 1, eternal inflation. We need to fix how you picture the Big Bang. It wasn't an explosion in space, it was an explosion of space. Think of the universe as a pot of boiling water. The water is a high energy field constantly expanding. In this pot, bubbles form. These bubbles are spots where the energy cools down and stops expanding so fast. Inside the bubbles, you get matter. Stars, galaxies, us. Our entire universe is just the inside of one bubble. We're trapped in it. But the water around us, the space between bubbles, is still expanding faster than light. That pushes the other bubbles away forever. We can't see them and we can't reach them unless we bumped into one early on. Remember that cold spot theory 2, the many worlds interpretation. The bubble theory separates worlds by distance. This next one separates them by luck. In the quantum world, particles are indecisive. An electron can spin up and down at the same time. This is super-p position. Usually, we say the particle picks one state when we look at it. But physicist Hugh Everett asked, what if it doesn't pick? What if the universe just splits to handle both options? In world A, the electron spins up. In world B, it spins down. Both versions of the universe are real. Both versions of you are real. This happens constantly, trillions of times a second. For every atom in your body, reality fractures. You're basically a walking logic gate. If you are enjoying this existential crisis so far, please hit that like button and consider subscribing. It genuinely helps the channel survive against the void. Also, there is a new feature called Hype. If you want to really help this video break out, please go ahead and click that Hype button. It makes a huge difference. Theory 3, brain cosmology. If infinite bubbles and splitting timelines aren't enough, let's try extra dimensions. String theory suggests our universe is like a slice of bread in a giant cosmic loaf. We're stuck on the crust. Physicists call the slice a brain and the space around it the bulk. This actually solves a huge problem. Why is gravity so weak? Think about it. A tiny fridge magnet can pick up a paperclip. That little magnet is fighting the gravitational pull of the entire Earth and winning. String theory says gravity is unique. It's not stuck to our slice of bread. It can leak off the side into the bulk. It feels weak to us because it's diluting itself across other dimensions. The creepy part, there could be another slice of bread, another universe millim away from your face right now. Theory 4, the simulation hypothesis. Finally, let's stop talking about physics and talk about information. Zoom in on a video game. Eventually you see pixels. Our universe has a similar limit called the Planck length. Below this size, geometry breaks. Is this the pixel density of our universe? Then look at the speed of light. Why is there a speed limit? In a computer, information can only move as fast as the processor can render it. Think of light speed as the universe's max ping. The logic here is simple. If a civilization can build a realistic simulation, they'll probably build millions of them. So, statistically, what are the odds you're in the one distinct real reality? Almost zero. Look at your hand. If this is a sim, those aren't biological fingers. That is rendered code. And that sounds cool until you realize that if any of this is actually true, things get dark fast. Part 4, theoretical implications. If these theories are true, we're standing on a lot of trapdoors. If we live in the bubble multiverse, we have to worry about stability. We might be in a false vacuum. At any moment, a quantum fluctuation could trip the latch. A bubble of true vacuum would open up, expand at the speed of light, and delete the laws of physics. It would incinerate Earth instantly. You wouldn't see it coming because the light warning you would hit you at the exact same moment as the death wall. Or consider the Boltzmann brain. In an infinite timeline, it is way more likely for particles to randomly come together and form a single brain than an entire universe. Statistically, you probably aren't a person. You're a lone brain floating in space that formed 1 second ago, complete with fake memories of a childhood you never had, and in a second you'll dissolve back into chaos. Finally, quantum immortality. If the many worlds theory is true, there's a chance you can't die. Every time you face a life-ending event, the universe splits. In one, you die. In the other, you miraculously survive. From your perspective, you might just keep surviving, getting older and more broken, trapped in an eternity of improbability while everyone you know passes away. It's a lot to take in. It makes you feel tiny or maybe just incredibly unlucky. But let's try to find some air here. Part 5. Conclusion. Okay, breathe. We've gone from bubbles to branches to being deleted by a vacuum. It makes you feel small. But here's the thing. This isn't just scary. It's cool if the multiverse is real. Impossible is just a local word. If we're a simulation, we're complex enough to be worth simulating. And if we're just one bubble in a boiling pot, hey, at least we're the bubble that figured it out. We're basically just the part of the cosmos that finally grew eyes and started asking uncomfortable questions. So don't worry about which universe is the real one. They all are. And in a way, you're in all of them. Thanks for watching.